Yes, sir. Good morning.
Good morning, very good morning. Jai Hind. Shreyas, Parin Sabha, yeah, good morning. Megha, good morning. Meghana, good morning. Ashwini TR,
Yes, sir.
yeah, good morning.
Good morning, sir.
Good morning, Saurabh. Joshna, Mukunda, Anusha, Nagesh, Bhavna, Iranti Vikas, good morning, all of you. Pranav, Ruchita. Okay, fine. Very nice. I think we should start 84 now. Almost this class is full. Okay, Jai Hind everyone. Today we are going to start with a new subtopic, that is Module 2 Part B, microwave passive devices. So till now we have completed all our Z parameters, Y parameters, and then scattering parameters, S parameters. We also solved certain problems related to S parameters, Y parameters, and Z parameters. Then we also solved all the VTU question papers, and also I gave certain homework also. I hope you must have already done those homework, and if we can submit on Google class also, that is okay, or on WhatsApp also you can submit. And now we are starting with a new topic, that is microwave passive devices. So we all know the microwave. We have seen all the devices like klystron and other devices. Those are all your microwave devices. Now we have some kind of passive devices which are also part of our system, microwave system, which we need to know. All these passive devices are very important also, and we'll see how this module goes across. So we'll see the coaxial connectors and adapters. These are the passive devices, microwave passive devices, and then we'll see the attenuators. Attenuators are also part of the microwave passive devices. And then we have phase shifters. I'm going strictly as per the syllabus. And then we have waveguide T's, and then we have magic T's. So all these five topics will be covering one by one. First we see coaxial connectors and adapters, and then attenuators, and then phase shifters, waveguide T's, and magic T's. Now this why these passive connectors are required in a microwave transmission line. These are the part of your transmission lines, sections, subsections of your transmission lines. Now the coaxial connectors, we use it day-to-day life also, because this is coaxial cable is a transmission line. So we have two types of waveguides. There is two types of transmission line. That is, one is your coaxial cable, and other is your the waveguide. So these are the factors which very important for us, the devices which are very important for us when we discuss about the transmission lines. Now these coaxial connectors are they now there are two differences between the coaxial connectors and the waveguides. When to use coaxial connector, when to use waveguide. So we cannot use waveguide instead of coaxial connectors for certain applications, and vice versa. So it is all depending on what kind of applications the transmission lines are there. So as per that, we undertake this kind of. So as an engineer, you should be able to understand where I should connect the coaxial connector or the coaxial cables, and where I should use the waveguides. So it is as per your design, as per the requirements of the circuit, we have to undertake this. Now these coaxial connectors and followed by the attenuators. Now these attenuators are, all the name goes, it attenuates the signal basically. So sometimes what we want is in some certain applications, in the waveguide section or in the coaxial section, we need to attenuate the wave. We do not want full wave or the full power to surpass to the transmission line and get across to the load. So we want that only 30% of load, or like say 50% of the signal should be reaching the transmission line, the load, because of certain reasons. There are certain applications where you need only 50% of the signal is supposed to be reaching to the load. So that time what we do, we use these kind of attenuators. So when we use attenuators, it will do the just the job of the reverse of the amplification. Attenuation is the reverse of amplification. So then we see the phase shifters. So sometimes what happens is in the transmission line, when we have a signal passing through in some phase, and now we want suddenly we have to change it to the, because in the other end, in the termination end, we have phase which is in the opposite direction. So sometimes we need to have a kind of phase shifters in between the transmission line. So that means the input and output, that is the source and load, are not in the same phase. So that time what we have to do is we have to change the phase. Like once we have an input, so we have some kind of signal which is coming, and now at the output side, there is a signal, that means it can receive in the other phase. So if you directly connect the transmission line without changing the phase, you will not get anything in the load. That means you can't actually read anything. So then you have to accordingly change the phase as per the load. So once you do that, then you use these kind of phase shifters to change the phase from input to output. Once you do that using the transmission lines, so along with the transmission line, you put a one kind of connector. This is the passive devices, what we call phase shifters. Then you can probably able to detect the signal at the termination end or the your load. So once you have that, then your signal will be 100% available at the. So for that, you should understand whether my signal at the load and source are same, whether I can receive or transmit same. These are all the impedance matching is there or not. All that thing you need to see. Then we have waveguide tees. These are the tees which are used for hybrid junctions, where you want to split the waveguide signals into 2 parts, 3 parts, like that you will have. So these tees are used to bifurcate the waves in the terms of different phase, in phase, out phase, like that. So like that you have these kind of waveguide tees which are connected to the waveguide. Waveguide also part of transmission line. So when we have a transmission line, sometimes you want to split the signals by waveguide signals into 2 parts. So A and B. So that time we use waveguide tees and something like that. Then called magic tee. Magic tee, sometimes you have to use this magic tees, like no. Sometimes you in the certain applications you will have to use a kind of wave which I want to, one side I want in phase, other side I want out of phase, and in the third port I want that should be 180 degrees out of phase, something like that. All things can do with this magic tees which are there. So all that thing we'll discuss one by one. So first we see the coaxial connectors and adapters. Now for understanding the coaxial connectors and adapters, first we have to understand the coaxial cable construction. First of all, you have to know what is coaxial cable, what are the parts inside that, and what are the subsections in the coaxial cable. Then only you will be able to understand the connectors. So connector is nothing but a connector which is simple connector, which is used to connect male and female connectors, so that you can have a transmission line terminated at one end to other end. So this is a coaxial cable. You can see a simple coaxial cable here. Here, this is the core. This is the copper wire. This is the core. You can see a small rounder like this is a core of copper wire. Then we have an insulation. This blue color is an insulation. Then we have a kind of copper mesh, a wire, insulation wire. So this is also a part of wire. So this has got copper stripping like this, perforated copper cable. Then we have the outer cover, that is insulation, which is a plastic polyvinyl material used here to cover these things. So this is a kind of coaxial cable. So anyone who has seen the coaxial cable in your life, just to tell me. Yes. Anyone who has seen?
Yes, sir.
Where?
Sir, in dish means the dish antennas, the wire they put to the set-top box, no, sir.
Yes, very good. Excellent. Who is this? Rainak Sharma or Saurabh?
Yes, sir.
Who is this?
Sir,
And
me,
both,
Renu.
Rainak Sharma, yeah. Your voice, both voice are same. That's why. Okay, fine. Very nice, Rainak Sharma. See, in the normal dish TV cable, we have a coaxial cable. Now, this coaxial cable, we have a connector also. At the end of the cable, when we use the connector is there. So we crimp it. What we call is a crimping. So there is a called something called crimping tool is there to crimp the cable with the connector. The connector is separate, but the cable is there. Now I want to show you a similar kind of setup which I have, a wire I have got there. Now see, I'll just place it towards the video. Can you see the video? Can you see the cable?
Yes, sir.
Can you see? See, so this is the similar kind of a cable, but it is not coaxial cable, but it is a similar kind of setup. So it's a twisted pair cables with some kind. So what I made a copper wire in a hard this thing so that this is actually simulating the core of the copper here. This is the copper core of the copper which is coming out, and you can see the white portion which is in insulation between the. You can see this one. This is the your strip of copper mesh what I told you. So this is the mesh which is there, and then this is the outer covering. So this is the whole outer covering. This is actually simulating your coaxial cable, but the coaxial cable width is little wider. So this is thicker in the width. Now this is a very thin one, but all the parameters which are there all are similar to that. So you can able to understand how this system is there in coaxial cable. A similar system is existing in the coaxial cable. Once again, I'll repeat, this is the copper core where the signal is going. So what we call this is the positive end and this is the negative end. So signal, now sometimes you must have seen during dish TV connection, what we do, if the signal is not coming, we'll connect only this one. This portion we put in the cable see, we have on TV, we have a female connector, coaxial connector, and we along with this is a cable. I'm just taking a piece of cable. Now, assume that this is the full length cable which is there of coaxial cable. Now, in the end, what we do, we connect a cable connector here. So once the connector is there, this is your male connector, what we call. And the other end is on the TV, what is there, or the setup box, we have a female connector. So we put the male connector in the female connector and lock it. So now this portion, whatever is there, like what happens in the TV is like the signal which is there. This core is very important. The signal is coming through this core. Now this is the there to give the return path for the signal. This other that mesh which is what is there. So sometimes if you what happens if I pull it like this. See, if I pull this strap, this mesh and like connect it, if it gets touched with the core, inner core of the copper wire, what happens? Then what happens? The signal will get shorted. You must have already tried this in the your video signals. You try this today. If you can cut open the dish TV and you try to mix these two wires and try to put inside the female connector, then see what is the signal output on the TV. What happens is you will get the signal, but it will be distorted. You will get a lot of noise, a lot of things are there which will not be able to understand what the signal is coming. So once you clear this thing, if you isolate this, you have to, for that you have to make it separate like this, so that positive and negative is not shorted. So once you have that, the connector is like having a similarly this is connected to a connectors inside core, and then this is connected. There is an insulation in the coaxial connector also. We have an insulation coverage for this. And then we have this. It will touch with the other portion of this. Then finally we have an insulation which goes inside the curve. So once you have that, once you connect to do the connector, female and male connector, then the absolute signal will the flow in the transmission line. So this is a very important. Sometimes you must have seen this connector not connecting properly. Your signal is not coming properly in the dish TV. TV signals are not getting clear pictures are not there. So that time you cut open, your engineer. So you cut open, see what has gone wrong with the coaxial cable. So you open and see there could be some kind of shorting. So you take out the shorting. So many times I have done this. So suddenly in Doordarshan also we used to have this kind of set of coaxial cable antenna which is there on the top of the building. Earlier time, very old antennas, that is the Yagi Uda antenna we used to use for TV reception, Doordarshan. Now also we use in the villages we see the Yagi Uda antennas are there. Now it is all replaced by the parabolic dish antenna. All you can see the you can always see that parabolic dish. You can see the dish TV itself is a parabolic dish TV. Now here in the case of TV, the Doordarshan, we have Yagi Uda antenna. So that antenna is connected to the coaxial cable, and this is a coaxial cable acts like a transmission line. It is a transmission line, in fact. And when the signal is picked up by the antenna, the RF waves, and it is transmitted through the coaxial cable, and it will go to the TV. This TV is what? Nothing but a receiver, which is receiving the signal from the antenna, and it is giving you the display. So TV is a display. Actually speaking, TV has nothing to do with the signal. So signal, whatever is carrying, is done by the transmission line and antenna. So very important is if you are actually watching an IPL match or any kind of Doordarshan matches or anything programs, so it is just because of the antenna and the transmission line and the receiver, of course. The receiver is a TV which receives the signal, decodes, demodulates, and it gives you the output in the form of pictures and audio. So everything is there in this. The information is passed through this transmission line. That is the coaxial cable core, which is there. Signal is positive signal is in this, so that whatever information is there, you get here. Now sometimes what happens in such coaxial cable, so it is like some people I have seen in some campuses, we have a Hathway kind of dish TV is also there, where they have kind of different setups, and they send the signals in a different way to all receivers. There may be hundred people who are receiving from the same antenna and same coaxial cable. So there are some adapters which are placed so that I can split the incoming signal into two different, or like every one pair of cable, I'll put one adapter to decode the signal, and I will send it to different users. Different receivers can be used. So for single antenna and single reception, I'll decode the signal. I'll use only one antenna and one transmission line, and I'll split it into different 100 signals and using other adapters and other things. Then I'll give it to all different users so that they can watch the TV at the simultaneously. They can watch. So this is the concept which is there in a Hathway system. So this coaxial cable matters a lot. Now, why can't we use the waveguides in TV? When it comes to radars, we are using the waveguides. But when it comes to coaxial cable, why can't we use? That means why can't we use coaxial cable in radar system, radar transmitter antenna, or why can't we use waveguides in your TV? Any simple question? Anyone can answer this? We have already discussed. Raina Sharma, Deepak. We have discussed. No, why can't we use waveguide in TV? Your dish TV. Your dish TV is receiving. It's an antenna. So why can't I put a transmission line as waveguide in dish TV?
There will be lot of distortion, sir.
No, why there will be distortion? So you should tell me reason. It's not that, yeah, there will be some problems, but why? What happens if I connect a waveguide? So please understand practical point of view. We have discussed this. Anyone? Deepak, are you there? See, we already discussed this during our Lystron and other topics when we were talking. So these coaxial cables are meant for only low power handling capabilities. It is meant for only low power handling. So what happens in case of your dish TV, or in case of normal any kind of situation, what happens is we use even for reflex lystrons also. For certain type of application, we use your only coaxial cables only. because of low power handling capabilities. Now, the moment I increase the power in terms of like kilowatts, if it goes, and what happens, your transmitter is producing power in kilowatts instead of watts. So in reflex klystron, we found that the power handling capacity of the reflex klystron is very, very low. It's a low power device. So it was generally used to generate power of approximately somewhere around in milliwatts, or could be watts, something like that. So that time, what happens is I cannot use the waveguides. I have to go for the coaxial cable for efficient signal transmission. So what happens in a waveguide is different. Waveguide, what happens is when the power increases, when the power of the transmitter, like if I use a magnetron instead of klystron, if I use a magnetron instead of a klystron, where or a reflex klystron, whatever we learned, now the magnetron has got very high power generation capabilities. So in radar transmitter, we use the magnetrons as transmitters generally, RF solid state amplifiers, and also we use. Now in case if I use the magnetrons, then what happens? It generates the output in terms of kilowatts of power, 100 kilowatts, so like say kilowatts in power, and with high frequency. Now, when it comes to high frequency and high power, then we cannot use the coaxial cable. This is meant for only low power, high frequency. It can take any frequency up to 18 gigahertz. It can take frequency. There is no issue. High frequencies we use, for low frequencies we use normal transmission line. But the moment we go high for high frequencies, we use a transmission line which is a coaxial cable or a waveguide. So it is meant for high frequency only. But difference between these two is the coaxial cable is a low power handling device, and whereas the other waveguide is a high power handling device or the transmission line. So this you have to very, very importantly earmark, because otherwise if you are connecting a coaxial cable for high power transmitters, then your transmitters may burn, or the whole system may have sparking and all. So to avoid that, we connect the waveguides to handle the high power requirements of a transmitter. So that's why even if you connect a waveguide to a dish TV, what will happen? The signal you will not receive anything. You will not receive any signal there. So ultimately, what happens is there will be noise, as told by Rainak Sharma. So there you will not receive anything. Why? Because it cannot handle the low power. It has to have certain required power levels are required to transmission. There are two different modes are there. So TM, T modes, TM modes, and all different modes is used by different waveguides, transmissions and transmission lines and coaxial cables. So all these things you have to be very, very sure. So as an engineer, you have to make sure that why I am connecting this dish TV, you should be knowing the reason. Why I am connecting the waveguides to a radar transmitter, you should be aware. So these are the very important aspects of the coaxial cable and coaxial the waveguides. Any doubt in this? Rainak Sharma, any doubt in this? Deepak?
No, sir.
No doubt. Okay. So if a question comes from your regarding waveguide and coaxial cable, there may be a question which I am foreseeing this time. What are the difference between coaxial cable and waveguides, and what are the applications? Something other that question may come. So kindly explain it very nicely. This is the coaxial cable is this one. So waveguide is a structure with a rectangular structure. We have seen that it is there in the lab. I will next class I will get it. That is there. So that I will differentiate how these things are used. And once you have, there is something called some connectors called RF connectors, SMA connectors, sub miniaturized A-type connector. It is called. These are the RF cables which we use for the for the low power transmission and reception. So you should understand all these things, very important. So we saw this, the coaxial connectors. Basically, this is the structure of the coaxial cable. Now, as per the requirement, we so compare with this. Now we can see similar kind of this thing. This is the copper wire, and this is here it is white color, but there it is a blue color which is shown, because in the coaxial cable it is blue color in the standard. And then we can see the mesh which is there. I have actually pulling like this. So this is the mesh and then we have an insulation which is there, so you can see very close from the TV or the video. So this you compare with the your system. So if a coaxial cable question comes, please explain nicely how this coaxial cable is there, so that you can easily get good marks in this. So basically, coaxial cable connectors are used to connect cables to other devices and are specifically designed to maintain the shielding on the cable. The male connectors have a protruding metal pin in the center, which is called as core, and whereas the female connector have a receptacle to receive that thin pin. So you can see here. One second, hold on.
Sir, they have started from 8 days.
Okay.
They will coming in 5-10 minutes.
Okay, fine.
So nobody there to receive goods order.
Okay, I'll come. I'll stop the class and.
You just stop the class.
Okay, guys, I'm stopping the class. There is some important meeting has come up. Okay, we can start at around 11:30 if possible. Okay, take care. Okay, bye.
Thank you, sir.
Yeah.
Thank you,
I'm
sir.
just saving.
Thank you, sir.
Yeah.